Hi gentlemen, this is Mr. Holding, and this video is just looking at the first of our Year 9 assessment pieces, essential testing. So essential testing, we're looking at different tests for different foodstuffs in the food that we eat, okay, and this experiment is about that. So first of all, it's important that you read through this. The task, you'll be analysing a number of food samples to determine what nutrients they contain. You will then have to complete a scientific report, which is what this is. Okay, so if we go through this now, this is the usual stuff as per policy. All right, it's important that you read carefully through the introduction. Now, this has been done for you. Next one you're going to have to do yourself, but the introduction basically outlines the background of the information. So nutrients are essential substances needed for growth and repair in the human body. Nutrients can be split into 5 main groups: carbohydrates, proteins, lipids, vitamins, and minerals. Carbohydrates such as starch and glucose are nutrients that supply an immediate source of energy and also act as a backup supply. And proteins, they'll adopt a key role in bodybuilding as a bodybuilding compound while also adding cell growth and repair. So that's background information about the topic. It's not talking specifically about the experiment, just about the background of the things that we're going to look at. Next thing you'll see is our aim, and our aim always starts with to. So to investigate, to determine, to calculate. It's to do something. So in this case, it's to investigate the presence of different nutrients from a given sample of food substance. All right, and the materials are here. Now, the experiment we're actually going to do, other way, is investigation 3.1, which is in chapter 3.2 of Jack Plus. Okay, so if we look here, the title is Essential Testing, Investigation 3.1. There's the equipment, and it says, from your kitchen cupboard, select 5 foods to test. We will give you that. If they're sold, you might need to break them down. And the purpose is to predict which of your food samples contain starch, glucose, and protein. Okay, so we're testing for those 3 things. This test is actually going to take part over 2 lessons. So the first lesson, we're going to learn how to do the tests. So the iodine test, which is a test for starch, the Benedict solution test, which is a test for glucose, and a protein test, which is the copper sulfate and sodium hydroxide, which is a test for protein. Okay, and why are we going to do that? We're doing that because we want to know what a positive result is. Okay, so what does the iodine look like when you put it in a starch with starch? Okay, what does it look like when you put it with glucose and gelatin? What does the Benedict solution look like, a positive test, when you put it into glucose? Because obviously, if it's a glucose test, that's going to come positive. What does a positive test actually look like? So we need to know that. Once we've done that in the first lesson, we're going to get our food samples and then test them for starch, test them for glucose, and then test them for protein. And then you need to work out whether it's got which one each of your foodstuffs has got. So it'll be things like chips, croutons, egg white, but you'll know more about that when we get to them. So that's the experiment there. So what you'll need to do is read through investigation 3.1, have a look at the first part, which is the tests, and you'll do this test here. So you'll get a glucose, a starch, and a gelatin solution, as well as water, and you'll have to do that with all of them with iodine, then all of them again with glucose, and then all of them again with protein. That's the first lesson. And then you'll have to test your particular food samples. Okay, so once we've done that, we obviously need to go about completing our report. So as we work through it, okay, you need to do a diagram. So you would have seen here, okay, you've got a diagram such as this. It's labeled, it's clear, and that's what I'll be expecting from you drawn in here. Not some little tiny diagram in the corner. I want to use the whole space. I want to make it very clear, okay, outlining what you need to do. The labeled diagrams I should be able to see clearly. Now, you don't have to be an artist to be able to do this well, okay, but use a ruler, use if you're going to use a pencil, use a sharp pencil, okay, make it clear. Okay, next one is your method. Okay, your method, we need a couple of things here. First person, past tense. Okay, we write as it has occurred. So 4 test tubes were placed in the test tube. It's happened in the past. Even if you do this before you do the experiment, which I encourage you to do, you still have to write it in past tense. Your third person. Okay, it was done. You don't talk about I, we, me, or our. It was done. The beaker was picked up. The test tube was put in the rack. Okay, and it needs to follow a logical sequence in numerical order. Okay, so just like baking a cake, the order is important. There's no point putting all the ingredients in the oven for an hour and then taking it out and mixing it all, because it's not going to work. You have to crack the eggs, mix the flour, make the batter, then put it in the oven at a certain temperature. Okay, just the same with this. The order is important, which is why the method is numbered. So go ahead, and then you can go through here and follow the steps. Okay, and write down your method here. Okay. As we go over, we have to do our independent, our dependent, and our controlled variables. All right. So your independent variable, all right. The way that I remember it, the dependent always depends on the independent one. Okay. Well, the word gives it away. So the independent variable is what you change. Okay. So think about in this experiment what you are changing. Is it the type of food? Is it the test? Essentially, we are changing the types of food. Okay, so we're looking at different things. So we go from one type of food to another. All right, so the results will depend on the type of food. Okay, so there you can, it's a fairly strong hint there. So what do you think the independent variable is? What is it that you are changing? Okay, and as such, what's the dependent variable? What is changing as a result of something that you've done? Okay, so you need to work those two out there. The controlled variables are very, very important. They're everything else that we try to keep the same. Okay, so think about all the things that we kept the same in those tests. What were they? They may have been volume, they may have been temperature, they mean weights of food product. Okay, all the things that we might have kept the same to have a fair test, because if we don't keep them the same, it's not a fair test. Okay. Once we've done our experiment, we want to use our results table here. Okay, and you can see here we've got our food type. All right, so it might be egg white, chips, I don't know, cucumber, something else. You write the 4 of them down, and then it's a simple matter of going indicating where a cross or a tick. So if it's, I may have had, I don't know, elephant boogers, cross for starch. Yep, it had glucose in it, but no, it had protein. And I go ahead and do that. Now, that's a very simple table, so make it clear. Write it neatly. Take your time. Use a sharp pencil, so that it's clear for your reader. Okay, so once you've done that, make it clear, make it neat and tidy. All right, take your time, don't rush it. Finally, discussion. What was the purpose of conducting the control test with glucose, starch, and protein solution prior to using the food sample? So if we look back here, this was the control test here, okay, when we did the starch test, glucose test, and protein test. Okay, and I talked about it earlier in the video. Why do we do these tests? What's the purpose of doing these before we actually go and test the food? Okay, have a think about that. Why would you need to know the results of a positive test before you actually went and did something with an unknown? Okay, have a think about that. That will help you answer those. It's for 2 marks, and look at the space provided. Again, try and be as neat as you can. On the back here, we've got 3 more questions. Suggest a reason why it was important for the food samples to be the same size and why the same amount of solutions were added to each sample. Okay, have a think about that. Have a think about those controlled variables and why we have controlled variables. And you want to answer that as best you can. Why do you think it's important to have same size food samples, same quantities, all those types of stuff? In this investigation, we were to be repeated, what improvements could be made to the procedure to ensure a fairer and more accurate result? Okay, so again, you need to start thinking about how you did the experiment. In year 9 science, we're obviously experts in what we do, but we want to see how we could improve it. Okay, and your ability to think about what you did, think about the procedure that you took. okay, and propose improvements, improvements in controlling certain variables, improvements in measuring results, improvements in being able to compare things. That's what we're looking for here, and again, that's 2 marks. All right, what I would like to see out of all of this, it's not a great deal of work, okay, is that you take the time to think about your answers, that you take the time, you show me the courtesy of actually trying to present your work neatly, because remember, I have to read through it all and mark it, so a bit of a plea from me there. Yeah, I think that's pretty much it. So make sure you take your time, read through everything, like everything, read, read, read. Make sure you understand. If you don't understand, ask questions, ask yourself, ask the people around you, and take your time. Okay, I hope you find this helpful, and please speak to me if you have any problems.